Hello and welcome to this video where I will show you a step-by-step guide to creating your first complete ESP32 project. Although this project is rather simple in its scope, there are some important concepts that must be mastered as part of ESP32 development. Let's take a look at what we'll be covering. In this video, I will show you how to configure the onboard LED, configure the expressive button component, configure a callback on button press, and toggle the LED on and off on detecting a button press. Let's take a look at the circuit block diagram. The circuit we will use comprises of the ESP32 device and a single press button switch. In my case, I am using an ESP32 DevKit V1 device. The two poles of the switch are connected to the ground pin and the D15 pin, which is GPIO 15 on my device. The block diagram shows the ESP32, the switch, and their connection to a prototyping breadboard. You can use this block diagram as a basis for constructing your circuit. If you are using a different ESP32 device, you may need to adjust the GPIO pin that you use accordingly. In the circuit diagram, you can see that the poles of the switch are connected to the device ground and D15 pins respectively. We will configure the GPIO 15 pin to be pulled up internally to the ESP32, eliminating the need to provide a pull-up resistor in the external circuit. A pull-up on the pin means that under normal conditions, the pin will be logically high. This means that when the button is pressed, the pin is forced logically low. This we will define as being the active state of the pin and button combination. As we will see later, when the button is low, a callback function will be called. Let's start by basing our new project on a custom template, blink_LED_template. If you haven't already created this custom template, then please take a look at an earlier video I made about ESP IDF VSCode extension custom templates. There's a link in the description below. Let's copy the template project to a new location. In my case, I will copy this to a folder C ESP32 SRC examples. Once copied, let's rename the template folder button_LED. Now open VS Code and open this folder. In VS Code, open the new project folder button_LED. Use File, Open Folder to open the folder. In our case, my project is at SRC examples button_LED. We are going to use the expressive button component, which we will need to install from the expressive components page. In the ESP IDF welcome page in VS Code, press Components Manager button. This will open the expressive components website. It's worth taking a look at this website since there are plenty of extremely useful components for your future projects. In our case, we will be using just one component, the button component. So let's do a search for the button component. Enter button, press the search button, and we get expressive/button. So click on the component page, and this is the component page for the expressive button. Press install. The ESP IDF extension will now install the component. When installation completes, open the folder managed_components expressive button include. In this include folder, you will see the header files for this new component, which you will include, or some of which you will include in the source later. When making changes to the source, pay attention to any IntelliSense recommendations to help you add the changes a little more efficiently. Open the main.c file, which is under the main folder. We will first add the includes in the code for the button headers. So these are hash include IoT button Let's fix the spelling mistakes. So that's what we should have. Include IoT button and include button GPIO. Then we should change the tag to something more meaningful. Let's call that button. Then we need to add the definition hash define for the button the button I'm going to use, which is GPIO 15. As mentioned earlier, you may need to use a different pin on the device that you're using, but it's pin 15 that I'm using on my ESP32 DevKit V1 device. So let's scroll down. We can leave the blink underscore LED method. We can leave the configure underscore LED method. And now we're going to add a callback method. This callback method will be called when a button press is detected. Button down CB. So when the callback is called, the state of the LED variable, the S underscore LED state, will be inverted. So the logic will be inverted. So if it's false, it will become true. And if it's true, it will become false. Now we need to add the button configuration method. And this method looks like this. For the button config, this will be an empty configuration. GPIO underscore num is the GPIO number of the pin that we are going to use. And the active level for this is false. So we set that to 0, or low rather. So the active level is low. And we will disable the pull-up on this because we are going to define the pull-up later. GPIO pull mode. Here we define the pull-up mode for the button, and that is GPI pull-up only. And now we define the we configure the callback for the button. So we pass the configuration parameters for the button, and we pass a reference to the callback function. Catch any errors, and now we associate the callback function with the button. So that's everything configured for the button. Now we need to change the app_main method. Oh, I see there's an error there. If you see in app main, you'll see that there's is detecting an issue there. That's because on line 46 there is an extraneous /. So let's remove that. Everything should be resolved. So let's say configure button. So now we configure the button on app startup, and then in here we need to remove that line because we're not performing the blinking logic inside of there. The state switch we're not doing inside of there, and we can set the task delay to 1 should be good enough. Look for any errors. I can see that const is not spelt correctly. Any others? We can see if there are any errors because of the red line there. There are too few arguments on the GPI or button pressed down, and there should be a null in there. That all looks correct now. Now let's build our project. Press the Build button on the extension status bar. The build process can take several minutes to complete. Any unrecognized dependencies will be resolved during the process. After the build process completes, it's now time to flash the device. I am flashing to port COM3 using the Silicon Labs CP21OX USB to UART bridge driver. Press the flash button on the extension status bar. Once the flashing completes, press the button on your circuit a few times to check the LED turns on and off. Now let's monitor the device. On the extension status bar, press the monitor button. You will see that there are a couple of warnings. The first warning refers to the flash chip using a generic driver, but it has detected a Boyer flash chip on the device. We need to resolve that, and it's easy to do. In the root folder, look for SDK config, open that file, and do a search in there for Boyer. And you will find that it is, uncomment that and set that equal to Y. The second issue relates to the size of the flash memory on my device, which is 4 megabytes, not the default 2 megabytes. So we need to fix that in the SDK config file. So do a search on flash size and the 2 megabyte option, comment that out, and the 4 megabyte option, enable that and set that to equals Y. So now the flash size of 4 megabytes is enabled. Having made those changes, we need to rebuild the project. So press the build button on the extension status bar. After the build completes, flash the device again by pressing the flash button on the extension status bar. Now let's monitor the device again. Press the monitor button on the extension status bar. You will see that those warnings have now gone. Now if I press the button, you'll see that we get a button press down, so the callback is being called successfully. And the LED on my device is flashing off and on. Here are a few exercise ideas for you. I suggest you use this project as a basis and make any changes accordingly. Well, that wraps up this tutorial. I hope that you found this video useful and that your project works successfully. I hope also that you'll consider pressing the like button and subscribing to the channel. These things are free for you, but they really do help the channel develop. I will be posting more videos on ESP32 development regularly. If you have any specific ESP32 development project ideas you'd like me to cover, then please place them in the comments. Thank you for watching, and bye for now.